I am Anil Kumar. Welcome to my series on quadratic relations. We'll explore what are quadratic relations and also work on finite differences. The major topics which we'll be considering in this video are linear and nonlinear relations. We'll explore parent or base quadratic relation, characteristics of quadratic relations, explore intercepts, finite differences, linear and quadratic relations, finite differences and graph of parabola, explore graph of quadratic relations, and take up thinking and application questions. Let's begin with linear or nonlinear relations. Here we have a question for you. Identify linear and nonlinear relations from the given graph below. So the two terms which we are looking into are linear and nonlinear. Linear means a straight line. So and nonlinear will be not a straight line. So basically, when I say linear, it means what? Linear graph is a straight line. So that becomes linear. So all the graphs which represent a straight line will be representing linear functions. So that is simple. A is linear. So I'll mark L for linear. And that is nonlinear. So we'll say NL for nonlinear. This is again nonlinear. That is also nonlinear. This is linear, a straight line. And this line is also a straight line, a horizontal line. So that is also a linear function. So the lines you can see, they could be increasing as we go along. They could be decreasing. They could be horizontal. They could be vertical also. So you could have a line which is also vertical. The other three are non-linear functions. In this particular video, we'll explore more about parabolas. So the function which is shown in this graph is called a parabola. It could open down or upwards. Now these two functions shown represent quadratic relations. Right? This nonlinear function you later learn represents cubic function, right? So with this brief introduction, let's see some characteristics of our quadratic functions. So as I was saying, the parabola represents a quadratic relation. The base of the quadratic relation is y equals to x squared. We also call this as a parent function. You can say parent or a base quadratic relation. The graph is given here. I'll mark some critical points on this particular graph, which will help you to understand how to sketch parabolas, which will be a major exercise in this particular video. So one of the critical point is starting with 0 itself. If we make a table, let's say we make a table here for different values of x, we will write the values of y. So y values are actually square of the x, right? So y is actually equal to x squared. Perfect. So different values of x, we will write y values, which are actually equal to x squared. So if I take values of x as, let us say, minus 3, minus 2, minus 1, 0, 1, 2, or 3, and if I square them, what do I get? Let's calculate. Square of minus 3 will be positive 9. Square of minus 2 will be 4. 1 square, 0 square, 1 square, 2 square is 4, 3 square is 9. So these are the values for y. X and y forms a coordinate point. You will notice that these values are symmetrical. So if you go from 0 to this side, you will get 0, 1, 4, 9. And on the other side also, we do get the same set of numbers, 0, 1, 4, 9, right? So what do we interpret from here? That there is a line, this particular line is the line of symmetry. We call this as axis of symmetry. For y equals to x squared, this is y-axis, or x equals to 0. So the axis of symmetry equation is always the x value, x equals to 0. Since the two sets are symmetrical, it's a good idea to just see one side. Perfect? Right. So we got one point here, which is 0, 0, which can be marked here. And then the next point, moving right, we can take 1, 1. At 2, the value is 4. At 3, the value is 9. When we say symmetric, it means that this 9 will also be on the other side. Do you see that portion? Similarly, we have 4 at -2 and a point symmetrically placed for -1. So these are your critical points on a parabola, as you can see, right? So that is how we could actually sketch a parabola. As far as axis is concerned, we have axis as a mirror image. Every point on the right side will have an image on the left side, as you can see. Does make sense to you? Perfect. So that is what a parabola is. Now, let's answer the questions which are given here. Shape of the graph. Shape of the graph is always a parabola. Now, this particular parabola opens up. The vertex is this particular point here from where it turns. So vertex is the turning point. For x squared, it is 0, 0, the origin itself. So let me label this as the vertex. The axis of symmetry, which we have already talked about, is x equals to 0, the vertical line, maximum or minimum value. Well, when it opens up, we have a minimum value. And the minimum value is 0. The y value we are interested in. The x-intercept, and in this case, both x and y-intercept are at origin itself. So y equals to x squared goes through the origin. The curve of this function, or the relation, intersects x-axis as well as the y-axis at the origin itself. So those are the basic characteristics. Correct? Let's look into more relations. Well, we could have a quadratic relation where the parabola may not be starting from the origin, means the vertex may be displaced. So these are your transformed parabolas, or we can say transformed relations. We are going to learn about them in details in the next video. Again, if you want to write down the details, many of them are similar. The shape of the graph will always be a parabola. To figure out it opens up or down, you can clearly see it opens up. The vertex is this point. In this case, it is at 0, -2. Axis of symmetry is right there, which again is the y-axis, which is x equals to 0. Minimum value In this case, we do not have maximum, but we have minimum value of minus 2. So whenever you are asked for minimum value, it is the y value. The x-intercept in this case is this, which seems to be at minus 1.5. And it has two x-intercepts and at plus 1.5. The y-intercept is the point where the graph crosses the y-axis. That's the y-axis. And this point is, you could also write a coordinate point, 0 for the x value and the y value being minus 2. Now there are more characteristics about the quadratic function. One of the most important things which we'll always consider is the domain. Domain is possible x values. That is the independent variable, right? Which is always along the x-axis. So the independent variable is shown along the x-axis. Those possible values are all real numbers. So we have x belongs to real numbers. So there are no restrictions as far as the domain is concerned. However, the y values are restricted. So in this particular case, range is restricted. So we can say that the y values are greater than or equal to minus 2. Or we could write y is greater than or equal to minus 2 in a simple language. So for the time being, we'll use this inequality to represent the range. Let's take more examples. This is your practice question. What you need to do here is fill up all this, including domain and range. So let this be a question from the quiz. Have a good look at it. That is the vertex. The axis this time is moved to this point. You have to report the x value. Those are the x-intercepts. This is the y-intercept. It is opening downwards. Domain is all real numbers, but the range is less than or equal to 2. Now let's move forward to other types of questions. Here in question number 2, we need to write characteristics of the quadratic relation shown from the graph. So straight from the graph, we can always say that first thing it is a parabola, opens down, and then we can say what is a vertex. Vertex is this particular point which is at x equals to, well, this is minus 2.5. So each is 0.5 minus, and this is minus 1, and the y value is 3. Since it opens downwards, we have a maximum this time. So the maximum of 3. That really means that the range is y is less than or equal to 3. That is what it means. And that is how maximum value and the range are related. Perfect. Now let's look into the intercepts. Y-intercept in this case is 1. So you could write this also as a coordinate point 0 and 1. The x-intercept, we have two x-intercepts which are shown there. So the x-intercepts are at x equals to minus 2 and x equals to, now this is half of 0.5, which is 0.25, right? So these are the characteristics which you can provide for the given parabola. So I hope that makes sense, right? Now here is question number 3. It is a very interesting question. It says, we'll now talk about intercepts of quadratic relation. So let me first tell you what are the intercepts, right? Question 3 is, write possible number of y-intercepts. that parabola can have justify your answer. Now, when I say y-intercepts, it basically means the point on the y-axis where the graph will cross, right? So let us sketch a few graphs to understand the situation. We could have a parabola which could open downwards. We could have a parabola which could open upwards. We may have a parabola which is just touching the axis. Right. Well, in any case, you will notice that it is always going to cross the y-axis at one single point. So, possible number of y-intercepts are always 1. You should note that y-intercept is a point where x is equal to 0. So that is your x-axis, this is your y-axis. When x is 0, you get the y-intercept. So y-intercept I can write here as at x equals to 0, value of y. Is that clear? So that is y-intercept. So normally you could say 0b. Now let's take question number 3a. Well, it should be 3b, which is write possible number of x-intercepts. So we have to write possible numbers of x-intercepts that parabola can have. Illustrate with rough sketch. So again, let us make sketches and then we'll figure it out. So as I had drawn earlier, I could actually sketch parabolas like this. We could do like this, or we could do like this, right? We may have a situation where the parabola is opening downwards. So let me draw another one here, maybe like this. Now the question is, how many x-intercepts do we have? In this case, we have none. The graph is above the x-axis. In this case, we have 1. And here we have 2. So the number of x-intercepts are either 0 or 1 or 2. Does it make sense to you? So those are the possible number of x-intercepts. So if you have a parabola whose y-value of the vertex is higher than 0 and it opens up, there won't be any x-intercept. Correct? Let's move on and take the next question. Question number 4. It's a communication and thinking question. A parabola opens up with vertex at -2, 4. How many x-intercepts will the parabola have? Think about it and answer the question. Here is what you could visualize. It opens with the vertex at -2, 4. -2, 4 will be somewhere here. And since it opens up, we have to go kind of like this. And clearly, there are no x-intercepts. Is that clear to you? So, in such cases, you have no x-intercept. Next question is, a parabola opens down with the vertex at -2, 0. How many x-intercepts will it have? Again, let's sketch it. -2, 0 will be a point here. Opening down from here, how many x-intercepts? Clearly, there is only 1. And so option B is the right option. Perfect. Question number 6. Now we are moving out of this topic into a new topic, which is finite difference. You have learned earlier for linear equations that first finite difference is constant. So what you know about finite difference is that for linear equations, or we can say linear relations, first finite difference is constant. Based on this, we have question number 6. Use finite difference to identify whether the relation is linear, quadratic, or neither. Well, let me tell you that for quadratic, second finite difference. So second finite difference is constant for quadratic. Degree 2 relation, right? For cubic, it will be the third finite difference, okay? Now, what is finite difference? I hope you remember. What is finite difference and how do we find it? Well, first you should notice that the x values should increase by 1 or by a constant term. So if you look into the x values, 0, 1, 2, 3, 4, they're also increasing by same unit, right? Same unit. In that case, y2 minus y1 is your finite difference. So we saw y2 minus y1 is finite difference. Is that clear? So for each, we will do y2 minus y1. So in the first case, 5 minus 3 is 2, 7 minus 5 is also 2, 2 and 2 and 2. Now that means the first finite difference is 2. And therefore, this relation is linear. Correct? The next one here, we'll again do the finite difference and figure this out. 4 minus 3 is what? 4 minus 3 is 1, 7 minus 4 is 3, 12 minus 7 is 5, and then we have 7, and here we have 9. Well, that is not constant. So clearly, it is not linear. Now, we'll find the second finite difference. So this is our first finite difference, which is not constant. Now we'll find the second finite difference. That is, we'll repeat this process. When you repeat, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. Second finite difference is constant, so it is quadratic. Relation perfect. Let's figure out the last one here. So we'll find the difference between the consecutive terms. What we have here is 27 take away 30 minus 3. 24 take away 27 is again minus 3. 20 take away this is minus 4. 17 is minus 3 and 14 is again minus 3. However, it is not constant. So delta 1 is non-linear. Let's figure out if the next one can work for us. So let's find the second finite difference, which is the difference between these two. Minus 3 is 0, and that gives you what? Minus 4, that gives you minus 1. And here, minus 3 take away this is 1, and that is 0. Well, that is also not constant. So it is neither linear nor quadratic. So that is how we can, from the data, find out whether it represents a linear relation or a non-linear relation. Now here we'll summarize what we have learned so far, linear and quadratic relations. As far as equation is concerned, we'll call parent equation for a linear as y equals to x and for quadratic as y equals to x squared. General equation is y equals to mx plus b, and the general equation here is ax squared plus bx plus c. As you can note, bx plus c is the linear term, and we have an additional ax squared. Constant finite difference. So in this case, first, and in this case, second, finite difference is constant. Now about the graph. As far as the linear relations are concerned, your graph is a straight line. For a quadratic relation, it is a parabola. Now, straight lines could be rising, could be falling, could be horizontal, or could be vertical. As far as the parabolas are concerned, they could be opening upwards or downwards. So that is how a parabola is. Clearly from here you can notice that parabola has a vertex, and therefore we have range which is restricted. You can say limited for time being. We use the word technically as restricted. For a line, all real numbers. For domain and range. Perfect. So these are a few important things which we have considered so far. Now, let's move further and pick up a few other things. Here we have an exercise for you. We need to find the finite difference and graph a parabola. Question 7a. Complete the table for the equation y equals to x squared minus 1. So we are given this equation which represents quadratic equation since the degree is 2. So we have to look for the degree, the highest power. So if the highest power is 2, it's quadratic. Or better terms is degree of polynomial is 2. That means we are talking about quadratic relation. Clear? Now, we need to complete the table. We are given some x values here. We can substitute these x values and find the y value. Correct? So if x is minus 2, what is y? So we need some space to work out the calculations. So let's do it here. So if I do minus 2 square and then minus 1, I get 4 minus 1, which is 3. So I can write the value 3 here. For minus 1 square, minus 1, minus 1 square is 1, 1 minus 1 is 0. So this value is 0 for us. If I substitute 0, I get minus 1. If I substitute 1, 1 minus 1 is 0. For 2, 4 minus 1 is 3. And we get these points. These are the coordinate points. So at minus 2, we have a value which is 3. So let me write down minus 2 and 3, which is kind of here. At minus 1, the value is 0. At 1, it is 0. At 0, it is minus 1. At 1, it is 0. And at 2, it is 3. So it's kind of symmetric. Do you see that? So at 2, it is again 3. So using these points, you can always sketch the graph of the parabola and you can extend it. So we can draw a parabola like this. You get the idea. So we took some points to sketch the parabola. There could be infinite points. So that's the graph and looks like a parabola. Now, the question here is find finite difference to confirm that it represents a quadratic relation. So Let's find the finite difference and see what do we get. 0 take away 3 is minus 3, minus 1 take away 0 is minus 1, 0 take away minus 1 is plus 1, 3 take away 0 is 3. Now let's find the second difference. Minus 1 take away minus 3 becomes plus 2, and that is 1 minus 1 is also 2, and 3 minus 1 is also 2. So we confirm that second finite difference is constant. Clear? Now, that second finite difference relates to the equation x squared, and that confirms that it is a quadratic relation. Is that clear to you? So that is how you have to answer these questions. So the steps involved are, you have to take some key values. So these are key values. You could choose the one which are convenient to draw a graph and then connect them to plot. Let's move on and take the next question now, which is question number 8. Complete the table for the equation y equals to minus 2x squared plus 8. Find the finite difference to confirm that it represents a quadratic relation. Graph the equation. It is exactly same as the previous question. You need to follow each and every step, and let this be your quiz question. So this is your second question on the quiz. Now see, this is negative. So when the coefficient of x squared is negative, let me highlight, then the graph of the function or quadratic relation will be opening downwards. So from the equation, it seems that the graph will be kind of like this, with the vertex at this point being at 0, 8. So that is a hint. So you can now calculate the values, complete the table, and then sketch your graph. Question number 9, which is again similar. So here also you have to practice. Now the key here is that the coefficient, we call this as the leading coefficient. Since it is half, do you see the key values taken? They are multiples of 2. So the key values are multiple of 2 for easier calculations. Does it make sense to you? It is up to you. So choose the values which are good for your calculation and then sketch the graph. This parabola will be opening upwards since the leading coefficient is positive. Next question here, question number 10. Read the graph of quadratic relations. Write coordinates of the vertex, x-intercepts and y-intercepts. Predict if the leading coefficient A is positive or negative. What is the equation of axis in the given graph? So let's start with the very beginning from the vertex itself. So the vertex is given to us as the point. First read the x value, which is minus 1, and then the y value, which is 2. Then the x-intercepts. So these are the x-intercepts. We have 2 of them. So in x-intercepts, we need to write down the x values, or you could write both x and y coordinate value. In this case, it seems to be minus 2.50. The y value will always be 0 for x-intercept, and that is half of 1. So we can say 0.50. Is that clear to you? Then y-intercept. Y-intercept is a point where the graph crosses y-axis. In this case, it is at 1. X value is always 0 for y-intercept. Predict if the leading coefficient A is positive or negative. So A is less than 0. It is negative. Why? Because the parabola opens down. So if the parabola opens down, then A is less than 0. It has to be negative. What is the equation of axis for the given graph? So this is the equation of axis. We have to report the x value. X equals to -1 is equation of axis. Is that clear to you? Right? Two more terms which I would like you to add here is domain and range. Domain is all real numbers. Also written as x belongs to real numbers. And the range is less than the maximum value. Maximum value is 2. So we could write this as y belongs to the real numbers, but y is less than equal to 2. Is that clear to you? We'll talk about this nomenclature in another video, but you could write straight away that y is less than equal to 2. Question number 11. Well, it is exactly similar to previous question. So in this case, we are given a graph of a quadratic relation. Write coordinates of vertex, x-intercept, and y-intercept. Predict leading coefficient value, whether it is positive or negative. And then we need to write equation of the axis, right? So I'll take this as your next question for quiz. So let it be quiz for you. Question 4. Let's move on to question number 12 now, which says, thinking an application question. You can actually pause the video here, look into the question, answer, and then my suggestions. Question 12. Sketch a parabola with following characteristics. Axis of symmetry is -2, passes through origin, maximum value of 10. Okay, let's try to sketch this. We're saying axis of symmetry is at x equals to -2. So I'm drawing a dotted line here, which is x equals to -2. So this is axis of symmetry. Passes through origin, so the parabola passes through origin. So we'll mark a point here for the parabola. Maximum value of 10. Now, where will this 10 be? Maximum value of 10. Now, maximum will always be on axis. Remember this. Maximum is always on the axis of symmetry. Perfect. So we'll have somewhere here the maximum value of 10. Now we have 2 points. How do we sketch a parabola? We'll use a property of parabola here, and that is why we are categorizing it into thinking and application question. And the property is that we should have symmetrical points. So this is at 0, this is at -2. So we should expect another point same distance away, 2 units on the left side. So we should have a point -4 also. And now we can connect and graph the parabola. Perfect. Does make sense to you? So we can now graph a parabola, which will be a curved line turning at the maximum going through the origin. So this is your vertex, which is -210. We have a point here, 2 x-intercepts. So we have x-intercepts at x equals to -4 and x equals to 0. Axis is at x equals to -2. Is that clear to you? So that becomes the graph of the parabola. So that is how you could answer this question. Extremely important question from test point of view. So I'm again putting a star here. It is a level 2 question. Another thinking and application question, question number 13. A parabola is represented by the equation ax squared plus b. Find the value of a and b from the following information. Minimum value of minus 2 and the point 3, 16 is on the parabola. Okay, how will you do it? Well, if it is a minimum value, parabola is going to open upwards. Okay, and let's say this is the minimum value of minus 2. Okay, so we don't know what is the x value. Let's write x minus 2. And another point on this is 316. Let's say this point here is 316. Now it says find the value of a and b. How will you find the value of a and b? So now let's try to understand the equation, which is y equals to ax squared plus b. For this equation, what is the axis? Well, this equation, the axis is x equals to 0. So basically, this parabola is actually going through the y-axis, vertex is on y-axis, and that is how it should have been. Do you get the idea? So minus 2 is the value of b, and so from here we can say that the value of b is minus 2. So we can say b equals to minus 2. It is the y-intercept. Think about it. Is it correct? It is, right? Now we need to find the value of a. Since we know that the point 316 is on the parabola, it will satisfy the equation. So we'll substitute the point 316 in the equation, which now is of the form y equals to ax squared minus 2, since b is minus 2. Correct? And therefore, we can write down the equation by substituting the value 3 and 16. So I'll write 16 for y, 3 for x whole square minus 2. So we are using the point which is x value of 3, y value of 16. Correct? So we get 16 plus 2 equals to 9a. 18 divided by 9 is the value of a. So we get 2 as the value of a. So we could find the value of a from this information. And therefore now our answer is y equals to, a is 2 for us, 2x squared minus 2. That gives you the value of a as 2 and b as minus 2. Extremely important question once again. I'd like you to understand how we have got this solution. Go through it once again, right? And here is the next communication and thinking question for you. Question number 14. Write a possible equation of a quadratic relation which will not have any x-intercept, So I could give you a graph and then I think you can write down the equation. No x-intercept means we could have a graph kind of like this, or we could have a graph like this. In either case, there is no x-intercept. So this graph could be written as y equals to x squared, let's say plus 1, and this graph could be y equals to x squared, which is negative since it is opening down. So what you notice here is that if the vertex is below the x-axis and graph opens downwards, there won't be any x-intercept. Perfect? So that is how you could do it. Now we are at the end. Here is the last question for you. It says a parabola opens upwards with a vertex of 3, 0. So the parabola opens upwards with a vertex of 3, 0. What can you say about the intercepts and the equation of x's? So you have to write what is the x-intercept, what is the y-intercept, and what is the x's. So it says, let's look at it once again. A parabola opens up as shown here with the vertex given to us, right? What can you say about its intercepts and equation of x's? So clearly, equation of x's is the x value of the vertex. So we have x equals to 3 as equation of x's. Now, y value is 0. That means what? Well, y value 0 means that it is x-intercept, right? So one of the x-intercepts here is at 3, 0. So x-intercept is 3, 0. And it has only one x-intercept. Perfect. So that is what you could say about it. So somewhere here, we will have the y-axis. This becomes your x-axis. So y-intercept, we could say maximum. It could be always, it is greater than 0. So it is positive value. You can say it is a positive value. It could be any, but it is definitely greater than 0. So these are the things which you could say about the intercepts and the axes from the given information. Does make sense to you? I hope that is kind of important to understand. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. So what we learned here is what are linear and nonlinear relations, what are the parent functions, what are the characteristics of quadratic relations, explored intercepts, and we answered many questions based on thinking and application. Perfect. In the next video, we will see how to calculate value of x-intercepts, and we'll take more application questions. Is that clear to you? But I'd like you to really go through this video and understand all the concepts. We are going to elaborate on these concepts further. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.